To Balvigan Bharti with your mentor Avila Sarkar. In this episode, we'll talk about some by rules or the rules that is adhere to the formula that we have derived. There are some limitations that is also you can say the mandatory rules to be known. Otherwise, you can fall into trap. So that all are to be discussed. So one by one, I will go into that. The first you can say can be named as observations or the rules, mandatory rules. Okay, these are mandatory rules. So the first of kind, which is related to the multiplication of two matrix. Let's say the matrix AB, if I multiply, and that if it is saying that is represented by an element, common element of order m into n, and with that I am multiplying b, which is represented the element by bij, and the order is n into p. Into n into p, then the result, if let's say we find as c, which is equal to cij, and it gives you the order. As I said, when you do multiplication, there must be the column of the first must be equal to the rows of the second, and then the order I will get is m into p. But the reverse of that, if I want to get the reverse of that, as C, you can understand that when I reverse it, what would be the case? This will be arrayed as Bij n into p into Aij m into n. So in that case, you can see the number of column for the first, if it is positioned first, so it will be treated as first, and the rows are not equal to p, not equal to n. Okay, so then I cannot do product. So the only condition for which I can do product is to p is to m, or otherwise m is to p, you can say. So this is equal to this only when m is equal to p. What does further it means? That this will become what? In, if I say m in place of p and m, will keep it. So this is order of n into m, and this is order of m into n. So that means ultimately we can say, so this is a both order have to be same, where this has equal to order where the at the same time where column is equal to rows, then you can say the other case the rows equal to column. For the first, if I say the for first, if it is placed like that, for first means A, if columns is equal to rows, then for the first, rows will equal to the column of the second. So then only the product we can say equal to B into A. Okay, but it is not necessary that both has to be a square order. That means square matrix. There could be anything, any rectangle matrix. But thing is that if I say the first is order of 2 into 3, so second must be of 3 into 2. Then only we can say these are commutative. This law is called the commutative law. So the commutative of a multiplication, commutative law satisfied only when the order is such it is reversed. So order of the first, if it is m into n, the order of second has to be n into m. Understood? If I take an example on this and try to prove it, practical example, I will go with 2 by 3, like means the lowest one. So let me take the A is order of 2 by 3, let's say 2 row 3 column. So 2 1 3 let's say 2, and I'm not going very high values, and 3. So and B, this is 2 cross 3. Okay, so now practically I will show where it's not possible. If I take any other order where the column of the first and row I will keep same, row of the second I will keep same, but I will not keep the row of first and the column same. So if I take 1 2 3, let's say, so here you can see this is 3 cross 1, but this is not equal to this. Now let's see what happens. Okay, so A cross B first I will calculate. So A cross B means you have to multiply this into this first to get the first element. 2 into 1 2, 3 into 2 6, 2 plus 6 8, and 3 again, 6 plus 3 9, and then this, there is no other option. So this into this, 1 into 1 1, 2 into 2 4, 1 and 4 5, 3 into 3 9, 5 plus 9 14. Now you see the order of this is equal to how much? 2 cross 1. What I am getting? 2 cross 1 as per the rule is okay. Now you remember this is A cross B. Now if I have to find B cross A, whether I can find it or not, let me check. B cross A means this will come first. So with the rule, the rows will be multiplied by column, but rows there is one term, so I can multiply with this and this. The second there is no value, so what would happen to this? So practically multiplication of this kind not at all possible. So equalizing is not at all applicable, as we cannot perform A cross B cross A, reverse of that, if in case the order of the first is not reversed here. Okay, now I will take some example extension of this where I will equalize, will reverse the order. Let's say I am taking this like 2 1 3, another I have added there. Okay, so now this is order of 3 cross 2, just reverse of this. Now let's see whether it is possible or not. So first I will find A cross B. Okay, so A cross B, the order you definitely get 2 cross 2 matrix as a result. So first this into this, 2 into 2, that I find already 9 I suppose, 2 into 2 1, 3 into 2 6 8, 8 plus 3, sorry that time I calculated wrong, that will be 11. 2 into 2 2, 3 into 2 6, 3 into 1 11. Okay, earlier one, but anyhow that is not possible. So this is 11. Second one, this multiplied with this, 2 into 2 4, 4, 3 into 1 3 plus 3, 1 into 3 plus 3. So how much? 10. So 10 will be here. Now next is your this into the this second row first column, 1 into 1 1, 2 into 2 4, 3 into 3 9. So this is equal to 14. 14 will be here, and the last one is this into this, 2 into 1 2, 2 into 1 2, 3 into 3 9. So this is equal to 13. So this you remember, this is A cross B. Okay, fine. Now what I will do, I will compute B cross A. So what is that? Now this will be my first matrix, this will be second. So rows into column. So now see, 1 into 2 2, and then this into 2 plus 2 into 1, so that is equal to 4. So this will come as 4. And now you see this is 2 cross 2 matrix. Okay, so now we are keeping B first, A second. So this row, this column. Okay, for this row, this column, that means equal to 3 plus 4 7. 7 will come here, Okay, this row is completed, but this row completed, this has finished there, but whereas I cannot multiply this with the third row. This is finished here. This is 3 cross 2, 2 cross 3. So that means column of the first, row of the second is okay. So if I put it here, let me put it exactly beside this so that I can understand. This into this multiplied, this into this multiplied, and the third one has to be multiplied this into this. So then that is equal to 1 plus 6. So that means equal to 7 also will be there. 1 into 1, 2 into 3, 6. So here 3 plus 4. Okay, the next one is, in this case I will get 3 cross 3 because 3 is coming first. And this and the next one is 1 into 1 into